Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, in today's class we are going to continue the chapter electricity. This is ninth period of this chapter. In yesterday's class we completely focused on one of the important effects of electric current. Yes, recall that what it is? You are right. It is heating effect of electric current. Then recall the definition of it. When an electric current flows through a conductor having some electric resistance, then heat is developed in it. This effect is known as heating effect of electric current, right? Then when the heat is developed in the conductor, is it possible to find out what amount of heat is developed? Yes. How? By using a formula. What is that formula? Yes, it is H is equal to I square into R into T. Then this can also be rewritten in another form. Could you tell that? Yes, you are right. It is H is equal to V into Q. How? We know that here I square into R into T can be written as I into R into T. What is IT? It is nothing but Q, because we know that I is equal to Q by T. Then I into T is equal to Q. What about IR? It is Vy. It is R is equal to V by I. Clear? Then V is equal to I into R. This is other way of writing the formula. H is equal to I square into R into T. Then what it is also called? This is called Joule's law of heating. Very important statement it is. Yes, recall the statement of Joule's law of heating. It states that when an electric current flows through a conductor having some electric resistance, then heat is developed in it. This heat energy is directly proportional to square of the current for a given resistance. Then it is directly proportional to resistance of the conductor for a given current, and it is directly proportional to time for which electric current flows, right? And with respect to this formula, H is equal to I square into R into T, we solved few problems as well. I hope that you have already practiced them. Next, in the last part, we discussed about important applications of heating effect of electric current. We know that lot of amount of electrical energy is used for converting it into heat energy. In spite of that, we will go for using some of the devices which work on heating effect of electric current. If you want to name some of them, as one is electric heater, second one is electric iron box, third one is electric bulb, and fourth one is electric fuse. Among these, in our syllabus, we have got information about an electric bulb and electric fuse. Now, could you tell the energy conversion takes place in electric bulb? Yes, it is electrical energy into heat energy, then light energy, right? Name the filament used in an electric bulb. It is tungsten. Then and its atomic symbol is W. What are its important properties? We all know that it has high resistivity, nothing but high electric resistance. And second one is it has high melting point. How much? It is of about 3880 degrees Celsius. Right? Next. And to give a long life to the bulb as well as filament used in the electric bulb, we go for filling the bulb with a chemically inactive gas. What is that? It is either nitrogen or argon. Is it not? Then what is another device which works on a heating effect of electric current? It is electric fuse. Definition is important for this. You can define the fuse as a safety device which breaks the circuit automatically when excess amount of electric current flows through it, is called fuse. Then what is the energy conversion takes place here? Here also electrical energy is converted into heat energy. Then name the filament which is used in fuse. The filament is an alloy of, what is that? Tin and lead, right? So these are, and another very important point with respect to fuse is it is always connected in series, right? Along with which wire? Live wire, because the main supply of current will be in the live wire. That is why it is connected along with the live wire. And one more important point is we will go for using different rating fuse. It may be 1 amp fuse, 2 amp, 5 amp, 10 amp, 15 amp. But usually 15 amp will be used for heating devices and 5 amp will be used for lighting devices. Okay. So this much was discussed. Now let's go for continuing this chapter. In the next part also, just I had given you bit information about the rate of doing work. What it is? It is called power. How do you define this? It is the rate of doing work. That is, whatever the amount of work is done is to be calculated for unit time. That is what we say the power, the rate of doing work. And we have the formula to find out power. What it is? It is work done divided by time taken. Then symbolic representation, it is P is equal to W by T. This is the general formula that we used to find out power, which we have learnt in our previous class as well. And one more definition is there, that is for electric power. Electric power. Then what is electric power? The rate at which electricity consumed by a component in the circuit is called its electric power. Alright. The rate at which electrical energy consumed or electrical energy consumed by a component in the circuit is called electric power. Then electric power can be found out by using the formula, that is power is equal to electrical energy used or consumed. Electrical energy used divided by time taken. And this can also be written as in symbolic form as P is equal to E by T. Even this was also known to us, right? Now, the power can be expressed in terms of different physical quantities. Now, let us come to know one by one. Before that, just I'll give you one more information. Now, could you tell the SI unit of power? Yes, you may go for using the formula. What is the unit of work done? It is joule. Then time, it is second. Here also, energy, joule. SI unit of time is second. So it is joule per second, and we call this joule per second as watt. Or it is joule per second. J, S raised to the power minus 1. Got it? Let's get some other information. Before that, you just go for writing from here. Power, its definition, then electric power, and write its definition with the formula SI unit. Right? Just we have come to know the formula to find out electric power. What it is? It is P equal to E by T. Its SI unit is watt or joule per second, right? Then when you say the power of a component E is 1 watt, you can say that power as 1 watt if a component uses 1 joule of electrical energy in 1 second. Here 1 joule per 1 second. So definition can be asked like this. Define the SI unit of electric power. You can define like this. Electric power is said to be 1 watt if 1 joule of electrical energy is consumed by an component in 1 second. Clear? Okay. Now, watt is the SI unit of power, and sometimes we consider this as smaller unit. Hence, we will go for writing the bigger units of power. Bigger units of power. Do you know what are these? Yes, I will tell you one by one. First one is, it is kilowatt. Kilowatt, KW. Kilowatt means what? How much? Kilo means it is 1000. 1000 can be written as 10 raised to the power 3. 10 raised to the power 3 watt. Kilowatt. Then another one is megawatt. It is mg. Sorry. mw. Mega means it is 10 raised to the power 6. Then watt. Gigawatt. You are also familiar with this. Gigawatt. It is GW. It is equal to 10 raised to the power 9 watt. Got it? Then we have the practical unit of power. Unit of power. Even you might have observed that in some of the electrical equipments, power is to be mentioned in other term. Do you know what is that? Example, the water pump. In that, you might have heard about half HP motor, 1 HP motor, 2 HP motor, right? Here, practical unit of power is, it is horsepower. Horsepower. And symbolically, it is to be written as just HP. Then we all know that watt is the unit of power. Horsepower is also unit of power. Then there must be a relationship between horsepower and watt, right? Do you know how many watt is equal to 1 horsepower? It is, you can recall this, 1 HP is equal to 746 watts. In the examination, there is a chance of asking, express 2 HP in terms of watts. Then you have to write 746 into 2. Whatever the product you will get, that should be written. Understood? Okay. Then, here, power is written as P is equal to E by T. You just go for solving E. What do you call E? It is E equal to P into T. E is electrical energy. So, this is the formula used for finding electrical energy. So, whatever the amount of electrical energy we consume in our house, is it to be calculated in terms of joules? No. Then we know that at the end of every month, we go for getting a bill from the electricity board, right? Karnataka Electricity Board. Then in that, how the electrical energy consumed is mentioned. Yes, it is in terms of units. We say that this time we have used 50 units of current, 80 units of current. Then what is unit? That is the commercial unit of electrical energy. Got it? Commercial unit of electrical energy. Commercial unit of electrical energy is kilowatt hour. It is nothing but unit. It is kilowatt R, or you can write kWh. It is also called unit. Then we all know that unit of energy or electrical energy is joule, and commercial unit of electrical energy is kilowatt hour. What is the relationship between these two? Let us go for writing that. Observe here. Here 1 kilowatt hour, it is equal to 1 into, kilo means how much? It is 1000. Watt, 1 watt is nothing but joule per second. Here I will write joule per second into hour. Convert this into seconds. We all know that 1 hour is equal to 60 minutes and 1 minute equal to 60 seconds. Altogether you can write directly 3600 seconds. Now seconds get cancelled. This is equal to 1000 into 60 into 60. 6 6 are 36, 2 zeros, 3600 joules. This is equal to 3600 into 1000. You can write 36 ones are 36, here 3 zeros and here 2 zeros. How much it is? It is 36 lakh joules. 1 kilowatt hour is equal to 36 lakh joules. Please do remember. And if you want to express this in scientific notation, you can also write 1 kilowatt hour as 3.6 into 10 raised to the power. See that decimal is taken after 3. 1, 2, 3, 4, 5, 6. 10 raised to the power 6 joules. And it is also 1 unit. Here 1 unit is equal to 1 kilowatt hour, which is equal to 3.6 into 10 raised to the power 6 joules. This is bit information about electrical power and electrical energy. Please do remember bigger units of electric power, practical unit of electric power, then commercial unit of electrical energy. This is commercial unit, and if you want to express that in terms of joules, this is 1 kilowatt hour equal to 3.6 into 10 raised to the power 6 joules. Even it was asked in the examination, express 1 kilowatt hour in joules. You will have to write this value. Understood? Dear students, in the beginning of the concept electric power, I told you power can be expressed in different physical quantities. Now let us come to know what are these. Here I will write. We all know that power, it is equal to W by T, right? And we also know that V is equal to W by Q. Then I go for taking substitution here. What is W? W is equal to V into Q. Okay, here I will write. It is VQ by T. Understood? Now this is equal to V into Q by T. What is Q by T? We all know that I is equal to Q by T. Hence we can write in place of Q by T, we can write I. So P is equal to V into I. Followed? See, first formula P is equal to W by T. Second formula P equal to E by T. Now we have written P equal to V into I. Even you can define electric power in another way as a power is said to be 1 watt when 1 ampere of electric current flows through a conductor maintaining the potential difference of 1 volt. Clear? Okay. So now we have expressed power in terms of voltage and current. In the examination there is a chance of asking express power or electric power in terms of voltage and current. You have to write P is equal to V into I. Here I will write power in terms of V and I. This is first one. Again we have one more. Power in terms of, you only will go for telling that I write P is equal to V into I. You all know that according to Ohm's law we can write R is equal to V by I. What is V? V is equal to I into R, right? Then go for substituting here. What is V? I into R into this I. Now you tell that it is I square into R. So P is equal to I square into R. Can you tell that power in terms of what? Current and electric resistance. Here I and R. Next, again power can be expressed in terms of other physical quantities. In terms of, yes, I go for taking P is equal to V into I. Then by Ohm's law R is equal to V by I. In the previous one we had taken substitution for V. Now let's go for taking for I. I is equal to, yes, solve this, V by R, right? Substitute here. So V into, what is I? V by R. Now P is equal to V into V, V square by R. Clear? Now the power has been expressed in terms of voltage and resistance. Here, voltage and resistance. So these are very important formula. In the numerical problems, often we go for using these formula because the first two formula, P is equal to W by T and E by T, most common formula used for finding power, which we have already discussed in our previous class, that is in 9th standard. But in 10th standard, we will focus on this. P equal to V into I, P equal to I square into R, P equal to V square by R. So once I go for writing all the formulas with respect to power, yes, tell one by one. Power is equal to, first formula, it is W by T. And second formula, P is equal to, it is E by T. Another formula, P is equal to V into I. Next, P is equal to I square into R. Then P is equal to V square by R. So power has been expressed in terms of different physical quantities. Here, power in terms of work done and time, power in terms of energy and time, power in terms of voltage and current, power in terms of current and resistance, power in terms of voltage and resistance. Got it? Now, here, just I go for writing the definition, that is 1 watt. How do you go for writing the definition of 1 watt? An electric power of an equipment is said to be 1 watt, where if it consumes 1 joule of electrical energy in 1 second. Right. Here I'll go for copying, writing this. The electric power of a component is said to be 1 watt if it consumes 1 joule of electrical energy in 1 second. Got it? And this is 1 watt is equal to 1 joule per 1 second. Even you can go for defining 1 watt in terms of these also. See that? Electric power of a component is said to be 1 watt if 1 ampere of electric current flows through a conductor having the potential difference 1 volt. Clear? Now you are going to copy from here to there. I'll tell you the order in which you have to write. First, you will write the definition of 1 watt. Then after that, without fail, you have to write and highlight this. Next, other writing. Bigger units of electric power. These are. And practical units. You can go for writing in small letters also. Mega, and this is giga. Practical unit of power, important. Horsepower, 1 HP is equal to 746 watts. Then commercial unit of electrical energy, kilowatt hour. Then 1 kilowatt hour has been written as 3.6 into 10 raised to the power 6 joules. We know that power can be expressed in terms of different physical quantities. All have been written. Usually these derivations will not be given. Only for the sake of understanding, I have written this information. So you have to copy as it is from there to here. Just copy this. Yes. Now we will focus on numerical problems. Just observe. I have taken very simple problems which have been given in the textbook. Observe. First one, an electric bulb is connected to a 220 volt generator. The current is 0.5 amps. What is the power of the bulb? Did you understand? See, we have the formula to find out power. Power is equal to W by T, power is equal to E by T, power equal to V into I, power equal to I square into R, power equal to V square by R. All these formulas, you have to recall them. Then, first we shall write that. As I said, it is very simple. Electric bulb is connected to a 220 volt. 220 is voltage. Next, the current is, that is I, 0.5 amps. You are going to find out the power. This is to be found out. Calculation. Now, see that to find out the power, what formula should be used? They have given two physical quantities, V and I. Hence, power should be expressed in terms of V and I. What is that? It is P is equal to V into I. Right? What is V? 220 volts. Already given in SI unit only. And I, it is 0.5. It is equal to 220 into 0.5 is nothing but 5 by 10 or 1 by 2. 0, 0. It cancels. 20 to 5 are. It is 110. Right? 110. What is the unit of power? It is watts. 110 watts. Therefore, the power of an electric bulb is 110 watts. Here all right. Therefore, the power of the bulb, that is electric bulb, is 110 watts. I hope that you have understood this simple calculation. Next we have one more. This is also very simple. Just keep observing. Look here. Don't copy. After solving this, then you can go for that. An electric refrigerator rated 400 watt operates 8 hours per day. In one day it is used for 8 hours. What is the cost of the energy to operate it for 30 days? Here they have asked you to find out the energy. Should it be expressed in terms of joules? Then if joule is not, then what you can go for? You can go for another one is kilowatt hour. Nothing but unit. If you, let's go for writing the data first. It will be easier. An electric refrigerator rated 400 watts. 400 watt is power. 400 watt. And we all know that here time has been given in terms of hour. Hence, it should be expressed in kilowatt, because to express the energy consumed in terms of kilowatt hour, it should be converted into kilowatt. It is 400 by 1000 kilowatt. I hope that you have understood. 0, 0, 0, 0 get cancelled. 2 2s are 2 5s are. Kilowatt. This is power. Then 8 hours per day. Time. T is equal to 8 hours per day, one day. Then what is the cost of the energy to operate it for 30 days? question has not yet been completed. Here I'll write at rupees 3 per kilowatt hour. They are given cost of 1 unit or 1 kilowatt hour. It is 3 rupees. Now you are going to find out the cost of the energy to operate it for 30 days. Here, cost per unit or 1 kilowatt hour. This is equal to rupees 3. You are going to find out the total cost. To find out the total cost, first you should find out what amount of electrical energy you have used in 30 days, right? Here, I go for writing. Could you recall the formula that we used to find out the electrical energy? Yes, you are right. This is E equal to P into T. Then what is the power? Power is 2 by 5 kilowatt, right? Then into time, 8 hours. It is per day. But here how many days they are given? Total 30 days. Hence, you can go for finding it for 30 days also. First, let us go for finding it for 1 day. It is equal to 2 8s are 60 by 5. It is equal to, cancel it. 5 3s are 15. 1 will remain 10. 5 2s are. E equal to 3.2 kilowatt hour. So this much amount of energy is used for 1 day. Hence, I go for writing here energy consumed or consumed in 1 day. Then for 30 days, E for 30 days, it is, I'll call it as E dash. It's equal to 3.2 into 30. In 1 day, we will use 3.2 kilowatt hour. In 30 days, 3.2 into 30 is equal to 0. 3 2s are 6, 3 3s are 9. After decimal, 1 digit. So it is 96 kilowatt hour. Okay. Now, you are going to find out the total cost. Total cost, it is equal to, for 1 kilowatt hour, 3 rupees. For 96 into 3, it is 3 6 are 18, carry 1, 3 9s are 27 plus 1, 28, 288 rupees. Understood? If you want to make the calculation in a simple way, I'll go for another method. Definitely you find it easier. First, let's go for finding the electrical energy consumed in 30 days. Here I'll write energy consumed in 30 days is equal to, that is E is equal to P into T. P into T. Now, total 30 days are there. So 30 days into P into T. Power is, it is 2 by 5 kilowatt. 2 by 5 kilowatt. And time for 1 day, 8 hours. 8 hours. Now you just go for this. 5 1s are 5, 6 are 30, 6 2s are 12, 12 8s are 96 kilowatt hour. I hope that you find it easier for calculation. Is it not? Next. Now you go for finding the total cost. Say 96 into 3 rupees. 96 units for 1 kilowatt hour, it is 3 rupees. It will be rupees 288. Or just you can write 288. And conclusion. Therefore, the total cost of energy. Therefore, the total cost of energy is rupees 288. Got it? Please go for copying from there to here quickly. Next, we have two more important statement problems. Just we shall move on to them. Observe. Third one. An electric motor takes 5 amps from 220 volt line. Here they are given current and voltage, right? Then determine the power of the motor. Understood? Means power should be in terms of current and voltage, that we have already known. Next, power of the motor and the energy consumed in 2 hours. Clear? Yes. Let me write the data. 5 amps, it is I equal to 5A, and voltage V is equal to 220 volts. Then you are going to find out the power. Next, you will also find out energy consumed in 2 hours. That is, time is given 2 hours. With that time, what amount of energy is consumed is to be calculated. Here, let's go for one by one. First, let us find out the power. What is the power formula? It is P is equal to V into I, right? It is V equal to 220 and I is 5. Multiply 0, 22 5s are 110. So power is 1100 watts. Clear up? Okay, next. You are going to find out energy consumed in 2 hours. Energy consumed in 2 hours. We have a formula. E is equal to P into T. Right? Power. If you want to express that in energy consumed in terms of kilowatt hour, so this watt should be converted into kilowatt. Hence, I go for writing 1100 by 1000 kilowatt. Clear up? Into time. Time is 2 hours. Or it will be just power, watt and time. To express that energy in kilowatt hour, power should be converted into kilowatt. Now 0, 0, 0, 0, right? Then 11 is there. 11 2s are 22 by 10. It is equal to 2.2 kilowatt hour. This is energy consumed. Understood? So we have answered for both the questions. Next, we have another important problem which was given in the examination as well. I go for putting star mark for this. First, let us write data. Before that, let's move on to the given statement. A bulb is rated at 220 volt, 100 watt. What is the meaning of this? It means 100 watt bulb is connected in the line having potential difference 220 volt. Got it? What is its resistance? This is first question. What is its resistance? Then 5 such bulbs burn for 4 hours. What is the electrical energy consumed? This is one thing. Second thing. And calculate the cost if the rate is rupees 4.60 per unit, that is per kilowatt hour. Understood? Now let's go for writing the given information. A bulb is rated at 220 volt. What does 220 volt indicate? It is voltage, 220 volts. Next, 100 watt. It is power of the bulb, 100 watt. What is its resistance? This is first question. 5 such bulbs burn for 4 hours. So number of bulbs, it is 5. How long they are to be used? 4 hours. So T is equal to 4 hours. Then what is the electrical energy consumed? So E should be found out. Next, calculate the cost if the rate is rupees 4.6 per unit. So it is cost per kilowatt hour, nothing but unit. It is rupees 4.60. You are going to find out the total cost. Let's go for answering one by one. It is quite simple. Observe it. You are going to find out the electric resistance. You know that voltage as well as power. Power can be expressed in different physical quantities. P is equal to W by T, P is equal to E by T, P equal to V into I, P equal to I square into R, P equal to V square by R. Right? Here V and R given, V and R as well as P. What is the relationship among these? P equal to V square by R. I am going to use this formula. In calculation, first part, P is equal to V square by R. We want R. R is equal to V square by P. What is V square? V is 220 into 220. Power, it is 100 watt. 10, 10, 10, 10 get cancelled. It is 22, 22s are. It is 484. R equal to 484 ohm. This is the answer for first question. Then how many bulbs are there? There are 5 bulbs. How long they are to be used? They are used for 4 hours. Then you are going to find out electrical energy. What is electrical energy formula? It is P into T, right? How many bulbs are there? There are 5 bulbs. What is the power of each bulb? 100 watt. As energy consumed is to be found out in terms of kilowatt hour, convert this into kilowatt. It is 100 by 1000 kilowatt. Time. How long they are to be used? They are used for 4 hours. Understood? Now 10, 10, 10, 10 get cancelled. Next, 5 4s are 20, 20 by 10. It is 2 kilowatt hour. So this much amount of energy is consumed. And you are going to find out, I am continuing here, you are going to find out the total cost if the cost per 1 kilowatt hour is 4 rupees 60 paise. Then I can write total cost as it is 2 kilowatt hour for 1 kilowatt 4 rupees 60 paise. It is equal to multiply that. How much it will be? 9 rupee 20 paise. Therefore, that you can go for writing the conclusion for all the 3. It is resistance of the bulb. Therefore, the resistance of the bulb is 484 ohm. 1. Second one. What is the electrical energy consumed? Energy consumed by the bulbs. How many bulbs? 5 are there. 5 bulbs. How much? It is 2 kilowatt hour. And what is the total cost for using electrical energy? And total cost is, it is rupees 9.20. Okay. I hope that you have understood the calculation. So by pausing the video, you have to copy from there to here with understanding. Okay. Copy this. Dear students, the syllabus, the first chapter electricity has been completed. Now we are moving to exercise questions. Let's go for one by one. First one I have written. Observe. In exercise also they have given very good number of questions and also very nice questions as well. Let's go for answering one by one. Observe. First one. A piece of wire of resistance R is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then the ratio of R by R dash is what? Generally you can understand that you can just go for guessing. There are some distractors, they have to be removed first. Look here, first let us understand the given statement. A piece of wire of resistance R, here this is the wire, its resistance is R. It is cut into 5 equal parts. See that? 1, 2, 3, 4, 5. 5 equal parts. 1, 2, 3, 4, 5. And these parts are connected in parallel. All these 5 parts. 1, 2, 3, 4, 5. See that? All these parts are connected in parallel. In this way. Then the equivalent resistance of this combination is R dash. Then what is the ratio of R by R dash? Generally you can think that this is the electric resistance of this wire is R. Electric resistance of these parts which are connected in parallel is R dash. Which one is bigger? Whether R is bigger or R dash is bigger? Yes, R is bigger. We know that when the resistors are connected in parallel, then the effective resistance decreases, right? So, R dash is smaller than R. Okay, R dash is smaller. That means R is bigger. Numerator bigger term, denominator smaller term. What will be the value? Will it be more than 1 or less than 1? It will be more than 1. Right or not? Yes. It is R by R dash is more than 1. See, 1 by 25, it won't come. 1 by 5, it won't come. So, we have these two possibilities. So, now it is a 50-50. First two are not at all possible. We have only possibilities either 5 or 25. But how do you go for guessing? I hope that this explanation has been understood, right? I go for calculation. See that here a wire is taken, its resistance is R. It is cut into 5 equal parts. Then what is the resistance of each part? Yes, it is, here I'll write resistance of each part. Each part, this is equal to R by 5. Right? It is cut into 5 equal parts. It will be R by 5. Next. And these are connected in parallel. What is the effective resistance? It is 1 by R dash is equal to 1 by R first resistance. Resistance of first part. Resistance of second part, resistance of third part, and so on. Total how many are there? 5 are there. I can write 5 into 1 by R. Clear? Now, 1 by R dash is equal to 5 into, what is R? Resistance of each part is R by 5. R by 5. Now, this can be written as 5 into 1 into R by 5 can be written as 5 by R. Now, it is 1 by R dash is equal to 5 5s are 25. 25 by R. Now, cross multiply. It is R by R dash is equal to 25. Hence, option D is correct. Got it? Did you understand this calculation? Even we can go for calculating this in another way. Look here, just here also. Observe. Here 5 resistors are, 5 parts are there. They are connected in parallel. Then equivalent resistance can be written as 1 by Rp. is equal to 1 by r plus 1 by r plus 1 by r plus 1 by r plus 1 by r. Right? Got it? There are 5. You can go for numbering also. 1, 2, 3, 4, 5. Next, 1 by. What is R1? We know that resistance of each wire is same because they are of equal length and the area of equal area of cross section. Its resistance is R by 5. It is R by 5 plus 1 by 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 R by 5. This is equal to, this can take the reciprocal. It is 5 by R plus 5 by R plus 5 by R plus 5 by R plus 5 by R. Take LCM. R is the LCM. Then denominator terms are same. You can just go for adding numerator. Numerator terms 5 plus 5 plus 5 plus 5 plus 5, 25. It is 1 by Rp. Rp, they are given equivalent resistance of these wires which are connected in parallel. It is R dash. They are given. So you can go for writing R dash. Cross multiply. R by R dash is equal to 25 by 1. 25 by 1 is nothing but just 25. Clear? Hence option D is correct. Next, we will move on to second one. Observe. Which of the following terms does not represent electrical power in circuit? They are given power in terms of different physical quantities. We have already come to know what are those. Just recall with me. Power, first one, P equal to W by T. Second one, P equal to E by T. Third one, P equal to V into I. Fourth one, P equal to I square into R. Fifth one, P equal to V square by R. See, first one, which of the following terms does not represent? See, I square R, it is power. I into R square, it is not. Right? V into I, it is power. V square by R, it is power. Hence, the correct option is, this is option B. Clear up? Okay. Now, I go for answering the third one. Third MCQ. Total 4 options are there. Go through this. An electric bulb is rated 220 volt and 100 watt. We have already come to know the meaning of this. 100 watt bulb is connected in 220 volt supply line, right? Then when it is operated on 110 volts, if the same bulb is connected in the line whose potential difference is 110 volt, then what will be the power consumption? Obviously, as the potential difference is different, power consumption will also be different. But which physical quantity will be same with respect to electric bulb? Yes, that is electric resistance offered. Is it not? Now, first I go for taking this 220 volts, 100 watt. Case 1. Here these are the 4 options. We are going to choose correct one. Here they are given 2 cases. Once it is connected in the line whose potential difference is 220 volt. Second, it is connected in 110 volts. Under this condition, what is the power consumption? Look here. Case 1. In this, they have given voltage V equal to 220 volt and power is 100 watt. Then as I said, there will be no change in the resistance of the electric bulb. So I go for finding R. So we all know that P equal to V square by R. Clear? Then R is equal to V square by P. What is V? It is 220 into 220 divided by P. It is 100. 0, 0, 0, 0. Get cancelled. 20 to 22 is a 484 volt. This is resistance. You may connect the electric bulb in the 220 volt supply, 110 volt supply, 150 volt supply, whatever it is, but the physical quantity resistance of the electric bulb does not change. Now case 2. In case 2, when it is operated on 110 volts, voltage is 110 volts. Resistance obviously it will be same. 484 is nothing but 22 into 22 ohm. Then the power consumed, here I am going to find out the power. P is equal to again V square by R, because V and R are known. What is voltage? 110 into 110. Then R, electric resistance, is 484. 484 is nothing but 22 into 22. I have written so because calculation will be easier. Now observe, 11 2s are 11, 10s are 110. 11 2s are 11, 10s are. Next. Now 10 into 10 by 2 into 2. Cancel. 2 1s are 2 5s are. 2 1s are 2 5s are. 5 5s are 25. 25 watt. Which option is correct? It is option D, 25 watt. Clear? Now, so we have answered for total 3 questions. Please copy them as it is. First write the question, write the option. You can, just they have asked to find out the suitable option. Choosing the suitable option, even you can go for just a calculation for your reference. And here also, here this question is directly. When you know the formula, you can go for choosing the correct option directly. Whereas in this case, you need again calculation. Yes, please copy from there to here quickly. Now, we will move on to 2 more problems, 2 more questions in that I have written 5th one. How is voltmeter connected in the circuit to measure the potential difference between 2 points? See that it is a circuit, a part of circuit is taken. In that I will go for taking 2 points. Here voltmeter, how it is to be connected? It should always be connected in parallel like this. The reason is it has high electric resistance. When it is connected in series, it alters or it varies the current flowing in the conductor or in the circuit. That is why it should always be connected in parallel. See, this is, I am going to make a complete circuit. This is plus and this is minus. Voltmeter, how voltmeter is connected? Voltmeter is always connected in parallel in the circuit. I'll write the answer. Voltmeter, it is answer. Voltmeter is always connected in parallel. If they ask you the question, why? What will you write? You have to write that voltmeter has high electric resistance. When it is connected in series, it changes the flow of current in the circuit. That is to be written. Okay. Now, let's move on to 6th one. Go through this. A copper wire has a diameter of 0.5 millimeter and resistivity of 1.6 into 10 raised to the power minus 8 ohm meter. What will be the length of this wire to make this resistance 10 ohm? After that, how much does the resistance change if the diameter is doubled? Got it? First, let us go for focusing on first sub question. Here, I'll write the data. Here, a copper wire has diameter 0.5 millimeter Here I'll write D is equal to 0.5 millimeter. Is it in SI unit? No. So convert that. Means it should be expressed in meter. It is 0.5 into milli means 10 raised to the power minus 3. Then meter. And we need to find out radius, because to find out the resistivity we have the formula. In that formula area is there, which is pi r square, right? R is needed. So 0.5 into 10 raised to the power minus 3 by 2 meter. Why? We all know that radius is half of the diameter. Next. And resistivity is already given. Rho is equal to 1.6 into 10 raised to the power minus 8 ohm meter. Next, what will be the length of this wire? You are going to find out L. Why? To make this resistance 10 ohm, R equal to 10. Now let's go for calculation. Here, we all know that resistivity can be written as R into A by L. R into A by L. We want length of the wire. So L is equal to R into A. What is A? Pi R square. Because in the wire, the area of the cross section will be in circular form. Like this. Assume that it has, think that this marker has the Y. Observe the end. What is the shape of this end? This end is circle. So it is pi r square. Next, divided by cross multiply rho. Clear? Let's go for taking substitution. This is equal to resistance. What is the resistance? It is 10. Then pi, it is 22 by 7 into, what is R? R is 0.5 into 10 raised to the power minus 3 whole divided by 2. Whole square is there, hence I go for writing this twice. It is 0.5 into 0.5 into 10 raised to the power minus 3 into 10 raised to the power minus 3 whole divided by denominator 2 is there. 2 is to be written 2 times into rho. What is rho? It is resistivity. Its value is 1.6 into 10 raised to the power minus 8. Clear? Now this is equal to, is there any possibility of cancellation? Chances are there, because in numerator here 10, 22, here 2 and 2 are there. Cancel it. 1s are 5s are, 1s are 11s are. Now this is equal to 5 11s are 55 into 0.5 into 0.5 multiply. It is 0.25 into 10 raised to the power minus 3 into 10 raised to the power minus 3. A raised to the power m into A raised to the power n equal to A raised to the power m plus n. So it is minus 3, minus 6. And here 10 raised to the power minus 8 is there. You can take that to the numerator. It becomes plus 8. Understood? Next, divided by 7 into, it is 1.6. This is equal to, again 55 into, now 25 is there, sorry 0.25. Let me write this as it is. 0.25 into 10 raised to the power minus 6 plus 8. It is 2 whole divided by 7 into 1.6 is there. I'll write this as it is. Observe, I'm going to convert these two decimals into fractions. After, say, I'm going to remove this point. Here 25, here 16. In the denominator, after one digit decimal is there, you take 1 0. Okay, and here after decimal we have 2 digits, hence I'll go for writing 2 zeros. Got it? It is 0.25 by 1.6 is equal to 25 by 100 divided by 16 by 10. It's equal to 25 by 100 into 10 by 16. See that 25 tens are 250, 100 into 16, 1600. Very simple. Now it is equal to 0, 0. Get cancelled. Is there any possibility of cancellation? Now let us write. You may go for cancelling it by 5. Because, or else let's do one thing. 55 into 25 into 10 raised to the power 2 as it is. 10 square is nothing but 100. Correct? Next, divided by 7 into 160. Now see it? 0, 0. Get cancelled. Here 2 8s are 2 5s are. This is equal to, I am going to write that here. This is equal to, now 55 into 25 5s are 125 divided by 7 8s are 56. Okay. Now let's go for multiplying this. Let us multiply this. 125 5s are 625. 62 is the cap. 125 5s are again 625 plus 62. 7, 8, 6. 6, 8, 7, 5. Got it? Divided by 56. Now go for dividing this. 14, 21, 26. Okay, let us divide that here. Here I will go for that. 6875 by 56. 56 ones are 56. How much will remain? 8 minus 6, 2. Here 1. Then carry down 7. 56 2s are 112. It will be 5 and this is 1. Carry down 5. Again 56 2s are 112. It will be 3 4. It is put decimal, take 0. 430. 8s are, no, 7s are. 56 7s are. After decimal, one digit is enough. 122.7. What is that? Meter. So L is equal to 122.7 meter. Clear? Okay. Now, sub question is there. How much does the resistance change if the diameter is doubled? Here I go for rubbing only this part. When the diameter is doubled, how much does the resistance change if the diameter is doubled? We all know that resistance is inversely proportional to area of cross section, right? Area is pi r square, where r square, r is nothing but d by 2 whole square. It is proportional to 1 by pi d square by 4. Proportional to this can be written as 4 by pi d square. Then can we write r is directly proportional to 1 by d square or inversely proportional to just d square? Is it not? Okay. Now r is equal to, when the diameter is doubled, when it is doubled to whole square, it is 1 by 4. Then what you can say, resistance decreases by 1 by 4 times, right? Because as the thickness increases, electrons will get more space for their movement. Hence resistance decreases. So resistance, when the diameter is doubled, the resistance decreases by 1/4 of its original value. What is the original value? It is 10. 1/4 of 10 means 2.5. So here we can go for writing that. Here only I will write. Here I will write. When the diameter is doubled. Diameter is doubled. Then the resistance decreases by 1/4 times of the original value. That is IE. I means it. E means est. That means it is R will be 1/4 of what is the original value? It is 10 ohm. It will be 2.5 ohm. Clear? Yes. Please go for copying from there to here. Copy that. I hope that you have written up to here. Okay. Dear students, before concluding today's class, just let me give you a small information. The first point is we have completed the chapter electricity, and second point, now we have been answering for the questions given in exercise. Total 18 questions are there. Today we have answered for 6 questions, and remaining 12 questions are to be answered in tomorrow's class. And please do practice as much as possible, and today's class is also very important. And one more important point is, as we have completed the chapter electricity, I'll give you unit test on that on Sunday. Okay, so with this, let us stop. Thank you.